problem was negative 20x plus 12y equals negative 24, and 5x minus 3y equals 6. And you had to solve the solution, the equations, and see if it was consistent, independent, dependent, or inconsistent. So you have to get it into y equals mx plus b form to see if to figure out whether it's parallel or not parallel, to figure out if it's consistent or independent. So you would subtract 20x from this side of the equation, and to get y by itself, and then on this equation oh wait, that's still the same one. And then after you subtract 20x, you would divide by 12 to get y by itself, and you get y equals negative 5 over 3x minus 2. And then for the other equation, you would subtract 5 from this side to get y by itself again, and then you divide by negative 3x to get y completely by itself, and you get y equals 5/3 x minus 2. And since it isn't parallel, it's consistent, and it's consistent independent.
Okay, so the only thing that we need to talk about before we let her sit down, we didn't really talk about dependent versus independent yesterday. So besides them being consistent, because of a graph, there's two different cases for consistent graphs. So there's the case where it would cross once, that's consistent, and then there's the case that it crosses and it's the same line, so it touches at every point. In this case, when you graph them, Grace, what does it look like?
I think it looks like it crosses, I can't remember. I think it's like,
Well, look at the equation. What can you say about the equation?
they have the same y-intercept. Y-intercept.
So she said they have the same y-intercept.
And they're so they would be I think they would be I can't remember.
Like everything that you have looks correct. So what you have, like for your problem, is correct, which is why I said it was okay. This should be a negative 20, I think.
Oh.
So
I didn't have the negative
yeah.
sign.
So if this, like she just did not write down the correct problem, so which is fine, and that's why I did not catch it. You're good. But this is supposed to be a negative 20 from the book. So that would make this a positive. So if you don't mind just making this
Okay.
into a positive, here's what's up. This should be a positive 5/3.
So then that would change it.
So then they are the same exact line.
Yeah.
So they're still consistent, but it's considered a dependent system because the lines are connecting at every single point. So we call that consistent and dependent. If they only cross once, then it's consistent and independent. So for the dependent, every solution depends on that other line. For the independent, it's just that one point that they're crossing. So she just copied the book problem down wrong, which is why the answers were slightly off, and it took me a little bit to figure that out. Any questions with that? So when you graph this, you're graphing it at the y-intercept of -2, and then you're rising 5, you're running 3. But it's the same exact line that you're graphing. Any questions with 21? All right, so the wonderful word problem, yeah, just throw that in the bin then. One of the word problems, other grades has for number 35. You know what, I have my book open, so you can just use that.
Alrighty, so the problem was you worked 14 hours last week and earned a total of $96 before taxes. Your job as a lifeguard pays $8 per hour, and your job as a cashier pays $6 per hour. How many hours did you work at each job? So what I did was the lifeguard hours were X and the cashier hours were Y, and then the total earnings were 96 and the total hours were 14. So I made the equation 8x plus 6y equals 96, and then x plus y equals 14, and then I both put it in y equals form so I could graph it, and then this was my graph, and it intersected at 6, 8, so that was 6 hours as lifeguard and 8 hours as a cashier.
So questions on creating the equations, because that's the hardest part for a word problem, is coming up with the equations that are attached to it. So for second equation, x plus y equals 14. The x plus y means those number of hours that you're working for the lifeguard versus the cashier, because there's two different positions that you're working. So those two different positions account for the x and the y, and the total number of hours is 14. So that's why that equation is x plus y equals 14. The second equation then would be how much you earn. So if you can group your equations together with like kind of thinking like terms, or what is the problem talking about, what's the same in the problem, that would be kind of how you want to think about creating your equations. There are questions on number 35. Nice job, Grace. Very nice graph too. These are all your graphs.
Do we have to do a graph for 45?
Yeah, you should have graphed all of them.
Every single problem.
Every single
I don't know.
Every
Like,
single
well, like, did you write it on the?
One word,
on the-
say to graph.
Okay, it doesn't necessarily say to graph, but how are you solving them?
Graphing into our calculator.
Okay, so if you graph it on a calculator, what should you do then, so that I can see how you solve it?
I just wrote graph on my
Did you? What? So you didn't, we weren't solving algebraically yet, because we're just graphing. But if you're graphing on a calculator, fine, but how do you show that you graphed it on a calculator? You still need to show me a little graph on your homework. So if you're using your calculator, okay, because some of them had fractions in them, but I still need to see the graph. So graph it on your homework still, even if you're graphing anything in the calculator. Those last two problems should have been graphed by hand. That's how we did the word problem in class together. I don't think the directions specifically said in class for us to graph them by hand, but we graphed them both ways. I'll get you guys in a minute. So if you look at number 36, most of you don't have 36 done. 36 says during one calendar year, a state trooper issued a total of 375 citations for warnings and speeding tickets. Of these, there were 37 more warnings than speeding tickets. How many warnings and how many speeding tickets were issued? So you could see the answer there. It was 206 and 169. This was an even problem, so make sure you check to see, did you get 206, did you get 169? But let's talk about how we can arrive at those two answers. So the first thing, kind of like Grace did with her problem, there are two variables, and we need to decide what those two variables represent. So Caitlin, what do you think the x would represent? Tickets, or what's the other option? Warnings. So one of them needs to be the number of warnings, the other one needs to be the number of speeding tickets. Because the number of warnings was listed first, generally that's what you would make for your x. So the number of warnings, and then y would be the number of speeding tickets. That was listed second in the problem. After you decide what your variables are, which yesterday in the word problem, that was already given to us, that's why we didn't list them separately. The second thing would be then just try and start coming up with equations. Reading through the first sentence, I can create an equation from that first sentence. So Caitlin, what equation do you have from the first sentence?
Y equals 375
Okay, so she said y equals 375 minus x. But that's probably not how you would initially set it up. Just reading through the problems, warnings and speeding tickets total 375. So 375 is the total from the combination of the number of warnings and the number of speeding tickets. So x plus y, because them together and means addition, has to total 375. The next sentence is a little trickier. It says there were 37 more warnings than there were speeding tickets. So we have to try and decide how can we write that. Sarah, did you have an idea as how to write the second sentence into an equation?
Y equals x minus 37,
And why did you say that?
because it said that there were 37 more warning tickets than warnings and speeding tickets, so you have to subtract 37.
Right. So that means the speeding tickets is the y. So if there's more warnings than there are speeding tickets, that means the number of warnings has to be less 37 compared to the speeding tickets. There's another way that you could also think about it. Virginia, how'd you think about it? So you could have also thought about it a second way. Either one will give you the same result. So in this case, you're saying the warnings would be the speeding tickets and then 37 more. But they mean the exact same thing. So both equations would get you the same answer. Because if I got this second one in y equals form, I would still have the same result. I'd still get x minus 37 equals y. So you just have to know that your warnings are 37 in addition or more than the number of speeding tickets. So here's my speeding tickets increased by 37 to show that my warnings would be more when I added that extra 37. Ethan.
I did 375 equals x plus 37.
That second piece needs to be in your second equation because this equation is only talking about the total number that we're dealing with.
I only did one equation.
You only did one equation, so you instead of using two.
And then I got it.
So the goal was to set up a system of equations. So the goal was to set up two in this case instead of one. Other questions? So if a problem asks you to graph it. If it doesn't say to graph and you're using the calculator, you still need to graph it so that I can see the work. Those last set of problems should have at least had a lot of work getting y by itself because those equations were not in y equals form. So if you're getting y by itself and you're using a calculator, I still need to see the work that goes attached with that. But again, if it says that you're solving and we're graphing and you're putting it in the calculator, it's fine, but I still need to see what you're graphing in the calculator. Questions? If you guys can just keep your homework on the side, I'll come around and check it in a minute. So today we're going to talk about solving with addition or the elimination process and substitution. So we're solving algebraically instead of practically. We'll still look at some word problems as well because all of these word problems can be solved using systems of equations. So we'll look to see how we can set up word problems a little more. So if you turn to section 3.2 in your notes, I'm going to talk about substitution first, and then we'll flip on the next page and we'll look at the elimination. But what does substitution mean in math?
Replacing something.
Yeah, so the key word is replace. So if we're using substitution, we're replacing one variable with an expression for a second variable. But replace is the key word. So we're replacing one variable with an expression that represents the second variable. The key word there is replace. Substitution is replacing something. So if you're being substituted in sports, you're being replaced with somebody else. So there are a couple of steps, which I think these steps are pretty straightforward. You've seen the substitution method before. So in the first step, it says blank one of the equations for one of its variables. Sometimes this step is done for you. So what are we going to put in that first blank? Paige? Replace. How about before we replace, we're going to solve. So we're going to solve one of the equations, and there'll be two because it's a system, for one of the variables. So you're either going to pick an x or y you're going to solve for it. Sometimes you don't have to do it, sometimes it's already an x equals 4 or y equals 4. Here's the substitute. Substitute the expression from whatever you get in step 1. So step 1 is going to say x equals something, or y equals something. You're going to substitute that expression from step 1 into the other equation. You can't substitute it back into the same equation. You have to take that new expression and plug it into the second equation, and then solve for the other variable. The third one, we want to solve for the other variable in equation from step 2. So you're getting one variable in x equals 4. You're taking that expression and you're plugging it back into a second. Once you have that, then you need to solve for the variable that's left in the problem. Sam,
Okay, never mind. I couldn't see what word that was.
this is step 1.
I thought that was like S.
Sorry.
I don't know.
Is that better? Finally, substitute the value from step 3 into the revised equation that you have for step 1. So it's a lot of substituting and solving. So you're going to solve and then substitute. Solve and then substitute. So you'll use that twice. You'll actually be substituting 2 different times. So there are 2 problems underneath here that we're going to just kind of go through the substitution method. There is usually like one method is good for one set of problems, the other method is good for the other set of problems. So there's something that you want to look for when you're deciding what to solve for. So if you look at A, like how do you decide which variable you want to solve for? It's a good reason to think of like the variable solver.
There's already a variable by itself in a problem.
So there's already a variable by itself. What do you mean?
Like it just doesn't have its coefficients.
Right, so you're looking at the problem and picking the variable that doesn't have a number in front of it. That makes it easy to solve for because then you don't divide. Sometimes when you divide, you have fractions in the problem. So this x here has no number in front of it. There's not a coefficient with it. That means it's easy to get by itself because you're just subtracting the y to the other side. Anytime you have to divide, that gives you an extra step of work. It might put fractions in the problem, and you probably don't want to have that. I mean, it works still, but it makes it a little more confusing. So that's the first step to solve. The second step then is to take this expression and replace it in the other equation. Well, the other equation would be the one underneath. So instead of x, you're replacing it with whatever x is equal to. So we're going to keep the 3. X is now 2y minus 2, or negative 2y minus 2. It's a quantity, so it goes in parentheses. And then there's a plus 4y. That doesn't change because I'm not replacing y, we're just replacing x, and then it's equal to 6. So there's the substitution part. We solved equation for the letter x. It was easy to solve for, it didn't have a number in front of it. You're taking the expression and replacing it, and now you need to solve again, because now we want to get y by itself. My equation only has y's in it. And that's why we use substitution, so that you have an equation with one variable to solve for. So get y by itself. So if we combine our y's, on the left side we have a negative 2y. On the right side, if we add 6, we should have a 12. And then you get y equals negative 6. So then you still need another solution or another piece to the solution because that's just our y. All these are ordered pairs where x and y meet. So take the y, go back into the problem up here. Negative 2 times negative 6 minus 2. And then I know what x is. What do you have? 10. Yeah. So x is 10. How do you write your solution? Right.
10 negative 6.
So 10 and negative 6. So if you haven't done so, see if you can solve B. So use the variable that is already by itself. It's okay. That might have a negative in front. Negatives are easy to solve for, or to get by themselves.
It is easy, right? Do you understand how it is?
Yeah, I'm back with it. I just wrote that down and then there. I realized right.
Yeah, I was thinking about a bullet test or something.
So Jenna, your first equation in y equals 4, what did it look like?
Y equals 3x minus 1.
So getting y by itself, because the only thing in front of it is a negative sign, that gives you 3x minus 5. And then Jenna, what'd you get for x?
X equals
So 10x is equal to 20, that means x is equal to 2. So when we go and plug 2 back in, your y value, Jenna, is
0. So,
oh wait.
oh, it's 6 minus 1.
Yeah. And then y should go first, not x. So you should have a 2, comma 1. Any questions with substitutions? So if you flip it on the back, we're going to do a couple of problems involving elimination. If you're eliminating something, that usually means you're getting rid of it. So we want to take a variable out of the problem. We want to get a variable to kind of vanish. How do you do that? What do you look for with using the elimination? Virginia? Okay, so she said you would subtract a variable. Why would we subtract? Isabella?
They would cancel each other out, so you have only one variable left.
How do they cancel each other out? So the elimination method, our goal is to cancel a variable from the problem. So our goal is to cancel one of the variables from both equations. Because why? Why can those variables cancel? Like, how would a variable just cancel from the problem? Sam?
Don't you like the opposite reciprocal?
You're so close.
The reverse reciprocal.
Because they have the opposite sign. same number. So you could say they have the same number with opposite signs, that might make more sense. So that means I'm looking for a 3 and a negative 3, a 5 and a negative 5, an 18 and a negative 18. That's how they eliminate. So something cancels or eliminates because it's the same number with the opposite sign. So to use the elimination method, you need to multiply one or both of the equations by a constant. A constant is a number. You're multiplying that constant so that you obtain coefficients that differ only in sign. That's the number in front of the variable that we're talking about up here. Add the revised equations from step 1 together. Combining like terms will cancel one of the variables, eliminate one of the variables, get rid of one of the variables, however you want to use that. So elimination, literally, one of the variables should go away from the problem because they have the same number in front but different signs. The last step, substitute the value that you obtained by solving the equations or by eliminating from step 2 into either one of the original problems. So you're going back to the original problem, plugging in a number and getting the other variable. So if you look down below, if you're a large writer, you might want to try and write a little smaller here. 3 problems on here, so just maybe write a little bit tinier. Sorry, Isabella. I knew you write a little bigger.
Yeah, I did do it.
It's okay. You can write smaller. It's fine. So if we have a 2x plus 5y equals 14, 4x plus 2y equals negative 4. Decide first what variable you want to eliminate. So Ethan, what variable would you want to eliminate in letter A?
I would like to get rid of variable y.
Okay. What would you multiply by to get rid of variable y?
I would multiply it by get rid of two.
Okay, so he said he's going to multiply by negative 2 and positive 5, which is fine. If you only multiply the top one by negative 2 because you want to save yourself a little bit of work, then you can eliminate the x's instead of the y's. But you kind of just decide you're going to get the same answer. So Ethan, it's okay that you want to multiply the top one by negative 2 and the bottom one by negative 5. Or if you just want to do one problem, one step of multiplication, we can just multiply the top one by negative 2, and then we can eliminate the x's by adding these equations together. So my 4x and negative 4x, that's the elimination part, they cancel. And then 2 and negative 10 make negative 8. Negative 4 and negative 28 make negative 32. So you get a y is 4. If you solve for the other variable, if we eliminate the y, then you'd have an x equals something. So after you have the one variable solved for, you go back, you plug that into one of the equations, and it doesn't matter which one. So if I want to plug it into the first equation, I'm plugging a 4 in place of y, and you're subtracting 20. So 5 times 4 is 20, I would subtract 20 and get negative 3. So this solution is negative 3, 4. Ethan, did you solve for x?
Yeah.
Yeah, and you got negative 3 still, correct? Questions? So how about the second one? What would you multiply by in the second one? Sarah?
I would multiply the first equation by 2 and the second one by 3.
And by doing that, what variables are you trying to eliminate? The y. So you don't have to eliminate y. You could have said, I want to multiply the top by 5 and the bottom by 7. That works too. But if you multiply the y by a 2, we get 24 for the top, and the y by a 3, we get 24 for the bottom. So it really depends what you see with the problem and what you want to eliminate. So that gives us 14x, 24y, negative 44, and then negative 15x, positive 24y, and positive 42. So the x's will stay, this time our y's are canceling, because I have the same number in front, but different signs. And we end up with a negative x and a negative 2. So plug it into one of those equations. Maybe you want to use the second one this time because the numbers are smaller in the second one. Totally your choice. So you should get 2, 3 for letter B. So see if you can solve that last one. Then we're going to look at one other problem, and it's the little word problem. Let me know if you have questions. And then you subtract them as long as you remember that everything gets subtracted. So you just make sure that like you did 2 minus 10 and not just subtract. Yeah, it's fine. So the result is the same. Just the way you. Anybody else have questions? So for letter C, you could multiply the top equation by positive 2 and then subtract your equations. Or you could multiply by negative 2 and then you would add your resulting equations. It kind of is like what you prefer, the process that you think is easiest for yourself. So if the numbers are the same in front, then you have to subtract the first equation from the second equation. If they differ, then you're adding them together. So whatever you decide is up to you, as long as you know when you're subtracting, every term gets subtracted. So I have walk B negative 2. So you go back, you plug it in, either equation. And anybody find an X? Ethan, what'd you get?
-4 and 3.
That sounds pretty good. Are there questions, Virginia?
When I was multiplying the first equation by -2, and I got that it equals -20, and so I subtracted 8, and then I got -28. So
Do you have these being the same sign or different? So because they're different, then you have to add the equations together. So you needed to add them. If they were both the same, then you would subtract them. Other questions?
I have a question about the homework tonight. When you say use both methods, do you have to use both methods on every equation?
No, so I don't want you to do all of them with substitution.
Yeah.
I want to make sure that you're picking one way or the other based off
Okay.
the way the equation is.
Do we have to graph any of those?
No. They're all solving. Alright, so I want to look at the word problem because I want to set this problem up. So the homework is 39 to 45. No, you're not solving them both ways. You're looking at the problem and saying substitution works for this one because there is a variable by itself. Elimination works for this one because there aren't any variables by itself. So I don't want you to just use the same method for all the problems. Alright, so for 4, the last problem at the bottom of the next page. So we're skipping a whole bunch. We're going to the bottom with the little word problem. To raise money for new football uniforms, your school is selling silkscreen t-shirts, which are those like t-shirts that, I don't know, the cheap ones that you can make that have the pattern on them. Like somebody probably took your shirts over here and made them in bulk. But short sleeve t-shirts cost $5 but are sold for $8. Long sleeve t-shirts cost $7 but are sold for $12. The school will spend $2,500, but they're selling them for $4,200. So a lot of information here versus what we're paying for this stuff and what they're going to be sold for. So the first thing you need to do is decide what your variables are representing. But in this case, we have short sleeve shirts and we have long sleeve shirts. So looking at the information that you're given, try and group the things that are the same together in one equation. So Sam, what do you think?
Alright, so I'm thinking one of our equations could be 4,200 equals 8x plus 12y.
Good. Because that's how much we're selling them for. So this equation represents how much we will sell the items for. So Sam, the other equation would be
2,500 equals 5x plus 7y.
and that equation represents the cost, right? So I would suggest using elimination here. You can multiply the top one by 5, the bottom one by -8, and eliminate the x's. Or you could do the same thing, try and eliminate the y's. Your solution should be 150, 250. So when you work through that and solve it, that's what your solution should be. So when you're coming up with an equation, try and group the things that are the same in one equation. You shouldn't have varying terms. So with the problem that Grace did, it was like total number of hours worked versus the amount of money that you were earning. So they don't go in the same equation. You want to keep them separate into two separate equations. So here, what we're selling them for versus what they cost us. So your homework tonight, the last problem, 55, is the word problem. But I have 47 and 49 up here that I'd like to see tomorrow. And there's a bunch of you that haven't done one problem yet, so maybe somebody like to try. Jenna, you'll try number 47. Hi, you'll try 49. Have an awesome day.